Today I will finish the chapter number 2. Okay, let some more to join the class. Okay, yesterday okay, now I'm going to start the class. Okay, yesterday all of you have done very well in the exam, in the test, weekly test 2. Okay, today I'm just going to discuss about the questions, yesterday's questions. Okay, because it's still in our mind, and if we clear the doubts or discuss this question, then it will be good for the concepts. Okay, so first question was that I gave that the first question of physics was physical quantity z given it is depend on two other quantities a and b, like a dot b. They are in a operation of multiplication. Okay, then the operation behind between these a and b quantities multiplication. Okay, and I asked to in the question just asked to determine the relative error, that is delta z. Okay, so for that, as I have done in the class, take this error is also given in the questions, plus minus delta b plus minus delta b, and you have to simply multiply this side and you have to neglect this term after multiplication. Okay, and finally we will get delta by delta by a plus delta b by b. Okay, this is done in the class. Okay, you see the class, you get this. The second question was that given z is equal to a to the power m, b to the power m, and c to the power m, you are asked to determine the percentage error. Okay, percentage error in z. So when you go for percentage error, what is percentage error? Delta z by z into 100%. This is the simple percentage error. Relative error multiplied by 100%. This is percentage error. So how we do this? See, there is exponent term. Okay, and last class I discussed that when there is exponent term, how we represent the error? Delta z by z, relative error. This is we take relative error because these quantities are in multiplication or division are related by multiplication or division operator. Okay, that's why we put relative error. So what will be relative error? Delta z by z and delta a by a plus n delta b by b plus l delta c by c. And when we go for percentage error, we will simply multiply by 100%. Delta z by z 100%. The percentage error n delta a by a into 100% plus n delta b by b into 100% plus l delta c by c into 100%. Okay, simply you have to write this. Now I have given questions from significant figures. Okay, you have to determine the significant figures. So first was 30.500. So यहाँ पर कितना होगा significant figure? There are 5 significant figures. Okay, 5. How it is 5? See, there are 5 rules in significant figures, and one of the rules says that if there is a decimal point present in the number, then ending 0 are significant. Though there is a decimal point here, so ending zeros will be significant. Okay, these two zeros will be significant because of the presence of this decimal point. So significant figure will be 1, 2, 3, 4, 5. Okay. Like actually in significant figure the zeros make the trouble. Okay, जो zero होता है वो trouble create करता है हमें significant figure find करने में. Okay, so you should be careful when dealing with the zero in case of significant figures. Okay, see. There are 2 zeros, they are present, 2 zeros are present, and there is a decimal point, so they will be significant. Okay, see, and there is another zero here, and it is also present between 2 non-zero terms, so it will also be significant. You see the rules applied in this number, then have the significant figure 1, 2, 3, 4, 5. Okay. The second was also same 601.00. How much significant figure? 1, 2, 3, 4, 5. 5. Okay. So there is decimal point. There are 2 ending zeros. Okay. Third was 0.0059. Okay. So see, here significant figure will be 2. Only these 2 terms will be significant. Okay. Why? See, there is a rule that when the number is less than 1, then what happens? When the number is less than 1, the zeros on the left side of the decimal point up to the first non-zero term, okay, are not significant. Okay, see, after the decimal point there are 2 zeros and 5 is the first non-zero term. Okay, the rule says that if the number is less than 1, the zeros to the left side of the decimal point up to the first non-zero term are not significant. So these 2 zeros will not be significant in case of this number. So significant figure will be 2. Only these 2 should be significant. Last term was that 4200. Here significant figure should be 2. Because there is also a rule that the terminal zeros, okay, in the absence of decimal point, the terminal zeros are not significant. Okay. These are 2 terminal zeros or ending zeros. Okay, and there is no decimal point present. So these 2 zeros will not be significant. Only these 2 terms will be significant. Okay, terminal zeros will not be significant if there is no decimal point. And if there is decimal point, the ending zeros will be significant. See, here significant figure is 5. But here, though there is no decimal point, so these 2 zeros are not significant. So only 2 non-zero terms. Okay, these 2 non-zero terms are significant. Okay, so this was about the significant figures. Now the third question was that given some numerical term, it multiply 2.758, and the answer of this was 2.00147. Okay, this is the answer. So we have to see number of significant figures in the first term is 1, 2, 3, 4. 4 significant figures. Okay. How much significant in this? Will be 3. Okay. How much significant figure in this number? Equal to 3, 4. Okay. See, there is a rule for multiplication when we are dealing with significant figures. The rule says that the result will contain the number as much significant figures as they are in the number with least significant figure. Okay, in case of division जो result है उसमें उतना ही significant figure होगा जितना कि जो number दिया हुआ है उसमें से जिसका least significant figure है उससे equal होगा. Okay, इसमें से इन तीनों में से least significant figure है this one. This number has least significant figure and significant figure is 3 for this number. So this answer must contain 3 significant figure. Okay, so we have to make this number up to 3 significant number. Okay, so what it will be 2.00. Okay, up to this we have to make it significant. See, we have also round it off when we neglect this term. Okay, see, there is 1, there is per 0 there is 1. Okay, so this is less than 5, 1 is, so we have to take this as 2.00. okay, this will be the answer. Okay, now next question was, I have given a number to subtract. Okay, 310 to the power 5 minus 2.5 into 10 to the power 4. Okay, so 39 1 2 3 4 minus 5 2 3. And when you subtract this, 3 5, then how much it will be? 3 7 6 and 3. Okay, this will be, so see, significant figure of this number is how much? For this significant figure is 2. Okay, 3 and 9, and for this significant figure is 2. Okay, sorry, significant figure no. In case of subtraction and addition, what we see decimal points. Decimal points. Okay, in case of addition and subtraction, when we deal with significant figures, we see decimal points. Okay, so what is the decimal point here? The decimal point is this 1, and how much decimal point there in this number? Decimal point 1. Okay, so what a rule for subtraction and addition says, the result must contain as much decimal point as there in the number with least decimal point. So here both the numbers same decimal point. Okay, this is 1 decimal point, this is 1 decimal point. Okay, so this result must also contain 1 decimal point. Okay, so to make it up to 1 decimal point. Okay, so how we do this? 3.65 1 2 3 4 5 into 10 to the power 5. Okay, see, there's 2 decimal points, so we have to round it off. Okay, now see, this is 5. Okay, when there is only 5 is present, what we see the preceding number. See, it is even. So from the rule of rounding up, we write 3.6 into 10 to the power 5. Okay, because when there is even numbers present before 5, we keep the number as it is by neglecting the 5. Okay, so this will be the answer. And the last question, is given that the side of a tube was given 7.203 meter. You have to make surface area and volume. Okay. So what is the surface area? X is equal to 6 into square of this term, 7.203. So how much it will be? This meter square. It was something like 311.2994. See, there is how much significant figure present in this number? 1 2 3 4. So you have to make the answer up to 4 is significant. See, up to this you have to make it significant. So there is 9, so greater than 5. So we simply write it down as 311.3 meters square after rounding it off, obeying the rule what was discussed. Now second thing is volume. It is known as volume. So volume is simply 7.203 whole cube. So how much it will be? 373.7147 something like this. And see, we have to also round it up to 4 digits. Okay, see, there is 1, this is 1 less than 5, so we have to write it down as 373.7. Okay, this is the answer. This is how we give it significant figure. This is how we do the arithmetic operation when we deal with the significant figures. Okay. Now I'll go to the last part of the second chapter, which is dimension of physical quantity. Okay, dimension of physical quantity. Okay, so as we have discussed earlier in the first class of this chapter, in the first class of second chapter, what we discussed that there are 7 base quantities. Okay, and all other derived quantities, derived physical quantities, can be expressed with the help of these 7 base quantities. Okay, with the help of these 7 base quantities, we can express all the other physical quantities. Okay, so what are these 7 base quantities? Those are length, then mass, then time, okay, then temperature, and luminous intensity, and electric current, and amount of substance. Okay, these are 7 base quantities. Okay, with the help of this, we can express any other physical quantities. Okay, like any other force, then capacitance. If we see the temperature, specific heat, all the physical quantities can be expressed with the help of these 7 quantities. So when we discuss about a dimension, then as we know in 2D, the 2 dimension, as we have read about the 2 dimension things. Okay, so this is x, y, this is x. Okay, in 2D plane or in 2D in 2D plane or in 2D surface, this is 2D plane, any point, okay, P, how we represent the point? By its 2 coordinates, x1, suppose x1 and y1. Okay, in 2D plane or in 2 dimension, any point can be represented with the help of their coordinates. Okay, by knowing the coordinates, we can easily determine the position of this point. Okay, location or position of this point. So these are 2 dimensions. So in 2D case, this is happened. So what 2 dimension means? There are 2 coordinates. Okay, so what it is said that in physical world or in physics, these 7 quantities are considered as 7 dimensions. Okay, like they are in x and y. In 2D, in 2D there is x and y. With the help of x and y, you can represent any point in 2D plane or 2D surface. Similarly, in physics or physical world, these 7 are considered as dimensions. Okay, like x and y, these are dimensions. With the help of this, we can represent any physical quantity. Okay, so how they represent this? Length, the dimension of length is represented as this dimension is represented in square bracket. Okay, dimension formula is represented in square bracket. Okay, for length, for this fundamental, so for the base quantities, what are the dimensional formulas? These are for length, this is L. Okay, for mass, we represent M. For time, we represent it as a T. Temperature, we represent it as K. Now, for luminous energy, we represent as candela. Okay, CB. Okay. For current, we represent as ampere. Okay, and for amount of substance, we represent this as mole. These are the dimension formula or dimension for the 7 base quantities. With the help of these 7, we can represent any physical quantity. Okay, we can deal with any physical quantity. And also from the dimension formula derived by these physical quantities, we can easily understand the nature of the quantity. Okay, nature of the quantity, we can easily understand when we represent that in terms of this dimension formula, in terms of this and base quantities, you can understand the how the physical quantity depends on length, how it behaves in changing temperature, and how it behaves when mass is increased or decreased. So this type of things we can easily determine from dimensional formula. Okay, so the definition of dimension is that the dimension of a physical quantity are the powers, okay, powers or exponents to which the base quantities are raised to represent the quantity. So what is the dimension? What is the definition of dimension? The dimension of a physical quantity are the dimensions of physical quantity are the powers or exponents. Okay. So who is the base quantities? Base quantity means those 7 quantities. Okay. Quantities are raised. Okay. The powers to which the base quantities are raised. What is the power? Okay. To represent the quantity. Okay. So suppose I'm dealing with force. Okay. So force, we know that what is the force? Mass and acceleration. So mass means right mass and acceleration means length into time to the power -2. Okay, and meter per second. Okay, length to time to the power -2. So how we represent this in dimensional formula? In terms of dimensional formula, for mass we will write m. Okay, for length we will write it l, and for time t. Okay, -2. Always we write it down in terms of m and t. Okay, first m, then l, then t. Now we do not shuffle these 3 things. Okay, do not shuffle them abruptly. Okay, always write mass first, then length and time. Okay, we choose this m and t because all the mechanical terms or mechanical terms in physics can be expressed with the help of this m and t. Okay. When you go for current, then another term like ampere will come in the formula. Okay, but all the all the terms used in mechanics can be expressed only with the help of mass, length, and time. That's why we generate that m and t form. Okay, m and t. Okay, so this is the dimensional formula of force. Okay, this is the dimensional formula. Okay, this whole thing is the dimensional formula. Dimensional formula. Okay, and what is the dimension? This is the dimension, and what is the dimension of force? The dimension of force is one. The dimension of force is how much? It is 1 dimension in mass. Okay, it is 1 dimension in mass, 1 dimension in length, and -2 dimension in time. Okay, see, this is the dimensional formula, and if you are asked to write the dimensions of force, then you have to write 1 1 -2. That is, force is 1 dimension in mass, 1 dimension in length, and -2 dimension in time. Okay, this is the dimensional formula of force, and these are the this is the dimension of force. Okay, So if you are asked to write the dimension of force, you have to write force is one dimension in mass, one dimension is length, and minus two dimension in time. Okay, and this if if you are asked to write it down the dimension formula, then you have to write m and theta minus two. Okay, these are the difference between dimensional formula and dimension. Okay, now we see for other terms. Okay, how to calculate the dimension formula. Now dimensional equation. Dimensional equation is nothing but one side there is the physical quantity, other side is dimensional formula in terms of base quantity. Okay, and then minus. So this is dimensional formula. This is dimensional equation of force. Okay, this is the physical quantity, and this is the dimensional formula for this physical quantity in terms of base quantity. Okay, so this is the dimensional. So this is dimensional equation. Okay, one side is the physical quantity, other side is the dimensional formula in terms of the base quantities. For that is in terms of m and t. Now let's see some examples. Okay, now suppose if you determine the dimension of pressure, how we determine the dimensional formula. Okay, suppose we are asked to write a dimensional formula for pressure. So we know that what is pressure? Pressure is force per area. Okay, force per area is pressure. Okay, so here what we do, we know what is force. Force is mass into acceleration, and we have already derived or already obtained the dimensional formula for force. What it is? M L T to the power minus 2. This is the dimensional formula for force. Okay, and what is the dimension formula for area? Now see, area. Okay, area is length square. Okay, so what it will be? L square. So dimension formula is L square. So how we represent this? Put this, divide this by L square, and L to the minus 1 by minus 2. Okay, so this is the dimensional formula for pressure. Okay, now suppose we are asked to write a dimension of volume. We know that volume is length cube. So so how we represent this? L cube. But see, what is the dependency of M and L for volume? So it is, so there is no mass dependent. There is no so that is, so volume doesn't depend on mass. Okay, so how we represent this? M to the power 0, T to the power 0. Okay, so what is the dimension of volume? The dimension of volume is 0 dimension in mass, 3 dimension in length, and 0 dimension in time. Okay, and we represent this in M to the power 0, L cube, and T to the power 0 like this. Okay, we do not write this like simple L cube. Okay, we write this in M and T formulas. Okay, we cannot write this like simply L cube. We write the final formula in terms of M and T form. If there is no M term, then we will write M to the power 0. Okay, or if there is the term is absent, then we write it down as T to the power 0 and M to the power 0. Okay, so now suppose gravitational constant. Okay, G. What is the dimension? The formula for G. So we know the gravitational force. What is G? M1 F by R. Okay, so G will be how much? Force from this formula, see, there is r square. If we have to eliminate g, or we have to find what is g, we have to put the r term to this side, right hand left hand side. Okay, so length square, r square is length square. There is two masses, okay? So mass square. Okay. So from this formula, we write down as suppose g is equal to how much? Fg r square into m1 m2. Okay. So this is how we write force with length square into mass square. Okay. So what is the dimension of force? As we have already obtained ml t to the power minus 2. Okay. The dimension of length square L square and mass m square. Okay. Now we just simple multiplication division. What it will be 10 to the power minus 1 and L cube t to the power minus 2. Okay. So this is the dimensional formula for gravitational constant. So from this formula, what are the things we can, how can we visualize, or how what are the informations we can give? See, so we see that how the mass depends on gravitational formula. G is proportional to mass. Okay, 10 to the power minus 1. So when mass increases, okay, in what happens? G will decrease. Okay, then when length increases, so G will increase. So from this we see how this any physical quantity related to the base quantity. Okay, how any physical quantity related to the base quantity. Okay, actually for this depends we have to look for all some other terms also. Okay, now we go for temperature. Okay. If we deal with 100 power units, temperature. How we represent the dimensional formula for temperature? M to the power 0, L to the power 0, T to the power 0. Okay. For temperature, we got K to the power 1. Okay. So simply K. So this is the dimensional representation, dimensional formula for temperature. M 0, L 0, T 0, K. Okay, K for temperature. Okay. Now we go for electric current. Okay. Electric current. So for electric current, the dimensional formula for current is simply ampere, or it is represent dimension in the terms of dimension formula. We represent by A, and we have to write this terms, and L 0 into A. Okay, this is the dimension formula for electric current. If we go for surge, okay, surge. So what is surge? As we have obtained a formula that I means current. Okay, I is equal to Q by T. Okay, you know this formula. You have got this formula in your syllabus 10th or 9th. So current is equal to surge by time. Okay, I is equal to T by T. So what will be surge? T is equal to I into T. So how we write this from this? Surge is equal to current, this I, into time. Okay. So what is the dimensional formula for current? Electric current, M 0, L 0, T to the power 0 into A, and for time is simply T. And you multiply this, what will be? M 0, L 0, T1, A. Okay. So this is the dimensional formula for electric, for current, for surge. Sorry, for surge this is the dimensional formula. T into A, T is time, this is ampere current. Now if you go for Now suppose we go for electric potential. Okay, electric potential. Okay, so it is what it is work by charge. Okay, what did I say? So if I ask you what is electric potential, then you know this thing. Okay, electric potential is what is it is the work done in bringing a unit positive charge from infinity to the position inside the field. Okay, this is the definition of electric potential. Okay, so suppose this is a Q charge is present here. Okay, and due to this charge, a field will be generated around this charge. Okay, there will be a field. Okay, so suppose we have to find the potential. Okay, due to this charge at this point. This is the R. So how we calculate this? The electric potential is what is the work done in bringing a unit positive charge, okay, from infinity to this position. Okay, so we have to calculate for electric potential. We have to calculate the work done for bringing a unit positive charge from infinity to this position. Okay, so this will be the electric potential of this Q charge at a distance r. Okay, this is the definition of potential, electric potential. Now, electric potential is represented by work by, since there is a unit positive charge, that's why we divide it by charge. Okay, work by charge. So, what it will be? So, work is work. What is work? It is force into displacement. Okay, displacement. So, what is force? M L T to the power minus 2. Okay, this is the formula for force, and displacement simply length. So, what is the work? That is the formula for M L square T to the power minus 2. This is the dimensional formula for work. And what is the dimensional formula for charge? This equals simply charge means current to time. Electric current is ampere and time is T. Okay, this is. So, how we write this? M L square T. L square T to the power minus 2 by T A. Now, this will be cancellation, summation of the exponents. What it will be? M C L square T to the power minus 3 here inverse. Okay. So this is the dimensional formula for electric potential. Okay, for electric potential, this is the dimensional formula. So this is how we calculate the dimensional formula. See, things are simple. So first we have to see what quantity is given, what physical quantity, suppose electric potential. So we have to see how it depends on the base quantities. Okay, how we can convert it to how we can so how it depends on base quantity. Okay, first we have to see. So electric potential, this is work by charge, and you know what is the work means force into displacement. Just we have to differentiate it, or we have to simplify it. Okay, we have to simplify this to this. This is physical quantity. Okay, this is direct physical quantity. This is electric potential, work by charge. So work means force into displacement. When we simplify force, what it will be? Mass into acceleration. Mass or into mass means m. Acceleration L P to the minus 2, and displacement means L. So this is the formula for work. We write it down here, and we have derived the dimensional formula for charge, which is T A. We write it down like this, and we just simplify this. Okay, or solve this. So how to find like it? M L square T to the power minus 2 A inverse. So This is the dimensional formula for electron. This is how we write down the dimensional formula for any physical quantity. Okay, we have to just simplify it up to the base quantities. Okay, a physical quantity is given for dimensional formula, you just simplify it up to base quantities. Okay, this is the thing you have to do in dimensional analysis. Now there is another thing that dimensional consistency. Okay, there is a term which is mentioned, dimensional consistency. So what is dimensional consistency? Okay, now suppose we are given 5 gram or two quantities. Okay, two results, 5 gram and 3 centimeter. Can we add or can we subtract this 3 centimeter from 5 grams? The answer is no. Because why no? Because the units are different. We cannot subtract 5 gram, subtract 3 centimeter from 5 gram, or we cannot add 5 gram with 3 centimeter because the units are different. So in any physical formula or in any physical relation, what is happened? The dimensions of each quantity will be same. Okay, any physical relation, in any physical relation, the dimension of each physical quantity will be same with the other. It must be same, otherwise they cannot be written like in the form in terms of formula. Okay, so suppose we take an example. We have get it in motion in a straight line, that displacement. Suppose that a body moving with velocity, initial velocity u at time t. Suppose the body is moving initial velocity u and acceleration is k. At time t, what will be the distance covered? Okay, suppose a body moving with initial velocity u, its acceleration is a, and at time t, what will be the distance covered by that body? So distance covered x minus x naught is equal to, so x naught is the initial position and it is the final position. So distance covered will be x minus x naught. Initial and final position will be ut plus half into x square. Okay. So this is the formula for that. Okay, a body moving with velocity, initial velocity u and acceleration a, and after time t, what is the distance covered? And this is the initial position, this is the final position, and this is the the distance covered. So in this formula, see that now what we see the dimension of each term. Okay, so what is the dimension of x? See, x is length. Okay, this is the position length. L. The dimension of x naught. What will be x naught? It will be also L. Now we see the dimension of ut. T is equal to, what is the dimension of u? U means velocity, so L t to the power minus 1. Velocity is meter per second, so L t to the minus 1. And dimension of t is t. What it will be? T cancel, it will be L. Now see the dimension of L, right? 8 square. Okay. See, we neglect the half because it is a numerical term, it has no dimensional unit. So what is the dimension of this? Dimension of acceleration is L t to the power minus 2 per second square, and t for t square, right? So what is the dimension of L of this term? Dimension of this term is L. So see, we write down or we derive this formula. Okay, and what we get? The dimension of each term. Okay, which are related, which are involved in this equation by addition or subtraction by every version. So dimension of each term in this complex equation, okay, dimension of each term in this complex equation are same. So dimension of x is L, here is dimension is also L, and this dimension is L. So this is dimensional consistency. What this dimensional consistency says, that in any physical relation, okay, the dimension of each term in any physical relation, the dimension of each term must be same. Okay, otherwise you cannot relate the terms. You cannot relate the terms in terms of addition or subtraction. Now there is important last important thing is that how to do the relation among physical quantities. With the help of dimension formula, we can do? We can find the relation. We can also find the relation among the physical quantities. Okay. Physical quantities. Okay. From dimensional formula, we can find the relation among the physical quantities. Suppose we're taking an example. The last part. As you know about as we have studied about centripetal force, okay? Centripetal force, okay. What is centripetal force? When an object is moving in a circular path, okay. When an object is moving in a circular path with uniform velocity, it will experience a force towards the center, okay. An object of mass m is moving with velocity v, okay. The radius of this circle is r. So when a body of mass m moves with velocity v in a circular path of radius r, it will experience a force towards the center. Okay. This is called centripetal force. Okay. So you have to find how the centripetal force related to these quantities m, v, r. How Fc centripetal force related to mass, velocity, and radius of the circular path. So how we do that? First we write Fc. Suppose is proportional to m to the power alpha. See, here you do not know the dimension. Okay. How centripetal force depend on mass. Okay. So how we write? We write it down as m to the power a. We have to find the a. Okay. What is a? It is the dimension for m. Okay. Or dependency of m which Fc. Okay. By knowing a, we can understand, we can realize the dimension, how m depends on centripetal force. So how centripetal force depends on m. How we know it? By knowing a, we can understand how centripetal force depends on mass. Okay. So how we write Fc proportional to n, or then Fc proportional to v Fc proportional to r. Okay, that's the radius of this circular path. V is the velocity of this mass, and m is the mass of this object. Okay, so now what we do? We write Fc is equal to k m alpha ma gb and rc. Okay, so see, Fc is directly proportional to m to the power n, directly proportional to v to the power v, and directly proportional to r to the power c. Okay, so we can write down as Fc is equal to m to the power alpha into v to the m to the power n, v to the power v into r to the power c. We can write this in terms of this. Actually, first we have to write this proportionality. Since Fc is proportional to m to the power alpha, v to the power v, and r to the c, we can write it down as Fc proportional to multiplication of these two terms. Okay. So when it deals with proportion, how do we bring a term? called constant. Okay, constant. Suppose k is a constant. Okay, constant. We don't know what it is. Okay, m to the power a, b to the power b, r to the power c. Okay, now what we do? We write down the dimension of left hand side and right hand side. Okay, so what is the dimension of force? What is the dimension of force? It will be m l p to the power minus 2. Okay, and what is the dimension of this term? M to the power alpha, m sorry, m to the power p to the power b, r to the power c. So how we write this? M means capital M A. What is the dimension of b? Dimension of b is l p to the power minus 1. So we write l to the power b. So l to the v. So v to the power b will be how much? L p to the power minus 1 to the power b. So L to the power b into p to the power minus b. Okay. So how we get L to the power b to the power minus b. And what is the dimension of R? R is simply length. L to the power c. So we sum it up. We multiply this. M to the power a, L to the power b plus c, b plus c into t to the power minus b. Okay. So this is what we get. From right hand side, what we get, left hand side, what we get? Force equal to m at the power minus 2. Okay, m at the power minus 2. This is the dimension of force, and this is the dimension of this term. Okay, m d r. Okay, so what we do now? What we do? We equate the left hand side equal to right hand side. Okay, so from here, what we do? We make left hand side equal to right hand side. Since both are same, that's equal to k, and k we neglect this. It is a constant, so constant term, proportionally constant. Okay, k is proportionally constant. So proportionally constant. We neglect this. Okay, in dimensional formula. So we equate left hand side to right hand side. When we equate left hand side to right hand side, what we get? Equating left hand side to right hand side. Okay, so what it will be? M L e to the power minus 2 is equal to, finally what we get? M to the power a, L to the power b plus c, e to the power minus b. Okay. Okay. So what we get from here? So sorry, there is some mistake here. M to the power a, e to the power b, and r to the power c. So what will be? M to the power a, L to the power b, e to the power minus b, and r to the power L to the power c. Okay. So b plus c, b plus c, e to the power minus b. Okay. So this is done. Okay. Now what we do? We equate the exponents. Okay. So what m to m, a is equal to 1, b plus c is equal to what is? Here exponent of L is 1, b plus c is equal to 1. So what is minus b is equal to? What is exponent of t? It will be, it is, what is this? It is minus 2. Okay. So we equate the exponent term. Okay. For exponent of m, exponent of L, exponent of t. Now solve this. Now from here, what is the k is equal to 1? See, b plus c is equal to 1, and b is equal to 2. So from here, what is c? So c is equal to 1 minus 2 is equal to minus 1. So solving this equation, what we get? A is equal to 1, b is equal to 2, and c is equal to minus 1. Okay. What are the formula? F is equal to the proportionally constant k, m to the power a, b to the power b, and r to the power c. Okay. If we write that the values of ABC, what it will be? M means m1, v what is b is 2, v2, and r is -1. So r by -1 is inverse of 1 by r. So this is the centripetal force. Okay, we have got the centripetal force from simply equating the dimensions. Okay, from simply equating dimensions, we get the centripetal force in terms of mvr. So what we get, f is equal to k and v squared by r. So this is what we get. Centripetal force equal to mv squared by r. So simply equating the dimensions, okay, we can derive the formula. Okay, simply equating the dimension, we can derive the formula. So this is the application of actually dimensional formula or dimensional equations of physical quantities. This is one application. Now let one more example quickly. Suppose time period of another example is time period of a simple pendulum. Okay. Suppose there is a pendulum. Okay. The length of this string is L. Mass of this bob is m, and acceleration due to gravity is g. Okay. So we have to calculate how this time period, time period of this pendulum, depends on m, l, and g, these three quantities. Okay, how this depends on the length of this thing, the acceleration due to gravity, gravitational force, and the mass. So how we do? We simply write it on like a previous one. T is proportional to m to the power a, proportional to L to the power v, and proportional to G to the power C. Sorry, G to the power C. Okay, so how we can write this? T is equal to, suppose a constant, proportional constant here, M to the power a, L to the power G, and G to the power C. Okay, so writing down the dimensional formula for left hand side and right hand side. So left hand side, if you write the dimensional formula T 42 m0 l0 t to the power 1. So dimension formula of this, how it will be? So dimension formula of C, I write the C outside, MA, LB, and GC. So what is the dimension formula of this? M to the power M to the power A, L to the power B, and for G, L. For G, what is G? This is acceleration. G is acceleration. Okay. So what is the dimension of acceleration? L e to the power minus meter per second square. So L. So if we write exponent C, so it will be L to the power C and T to the power minus twice C. Okay. If we simplify this, M to the power A, L to the power B plus C, and T to the power minus twice C. Okay. This is the dimension formula for time. This is the dimension of left hand side, and this is the dimension formula for right hand side time. Okay. Now equate both left hand side and right hand side. So equating left hand side is equal to right hand side. So how do we get? M0 L0 T is equal to MA LB plus C T to the power minus twice C. Now what we do? Now we equate the exponent term. Okay. So so A is equal to, from here what we get? A is equal to 0. B plus C, exponent of M here is 0, and exponent of here is B plus C. B plus C equal to 0. Exponent of time, here exponent of time is minus twice C, and here it is 1. So from here, by solving this, we get, so from here C is equal to minus half. Okay. So by putting the value of C in here, what we get? B is equal to half. Okay. So how we represent time? Time is equal to C, time over simple pendulum. C is equal to m to the power 0, L to the power half, and C means G, acceleration due to gravity. Okay, minus F. So how we write this? C root over L by G. Okay, so the time period of a simple pendulum is L by G, where G is acceleration due to gravity and L is length of the string of the pendulum. Okay, and C this is the time period of pendulum. And what is, and we know we have obtained the how we calculate the time period of simple pendulum. So in actual case, what is C? C is twice pi. In actual case, what is C? C is twice pi. So what is the time period of a simple pendulum? Twice pi root over L by G. Okay. This is the time period of a simple pendulum. Okay. This is how we calculate time period of a simple pendulum. So from dimensional formula, we derive up to this. Okay. But see, okay, by using dimensional formula, we derive up to this. Okay. We can understand how time of a single pendulum will depend on L and how it depend on gravitation or acceleration due to gravity G. Okay, we can derive with this, but with the help of dimensional formula, we cannot determine the constant. Okay, we cannot determine the constant with the help of this dimensional formula. But in actual case, actually, it is when you calculate or determine the time period, it is actually twice pi. Okay. Okay. So there is a drawback of dimensional formula. What is this? The drawback of dimensional formula is we cannot determine the constant term. Okay, we cannot find out the value of constant term when we write a formula or derive a formula with the help of dimensional analysis. Okay, so these are the things. This is things you have to practice. Okay, it is a very important topic, the dimensional analysis. So to this, I will stop here. In the next class, I will discuss. I will summarize all the chapter 2. Okay, what you learned, and I'll go for the chapter number 5. Okay. In the next class, I'll go for chapter number 5, which is laws of motion. Okay. There we see Newton's first law, second law, third law. Okay. These things. So this is the end of chapter number 2. If you have any doubts, then please write it down and send me in WhatsApp or any other means. So please read thoroughly the chapter number 2 and ask for any doubts. Okay.